Hi guys, today is March 23rd, so 3/23, okay? And today we're gonna do integration by substitution again, day 3. This time we're gonna look at how do we do this with definite integrals, okay? All right, so you look at this, okay, we're asking you to do find the integral from 0 to 1. Now this is new, right? Where we have the lower limit and upper limit. Okay, and you look at this, all right, and you go, okay, so there's an inside to this cubing function, right? It's x squared plus 1. And if we let u be that, this becomes u cubed. And if we take the derivative of the inside, the derivative of x squared plus 1, that would become 2x dx. And we have the x and we have the dx, but we don't have the 2. Well, we can fix that, right? Because it's just a constant, okay? So we're going to let u equal x squared plus 1, and then du becomes 2x dx. And so with this du, we pick up the x and the dx, okay? So I need the 2, so I'm going to write this, okay? This is going to be equal to the integral from 0 to 1, okay? And I'm going to multiply by 1/2 and also multiply by 2. So 1/2 times 2x, because really that's still this x right here. And I'm going to take this 1/2 and bring it out, okay? And then this is x squared plus 1 cubed, and then dx, okay? Now, this is my u, and the 2x right here, and this dx make up my du, right? Okay, so now the 1/2, this 1/2, I really don't need. I need it to put the 2 here, but I really don't need it as part of the integral. I'm going to pull that out. So this is going to be 1/2 the integral. Okay, and I'm going to hold off on putting these limits because I'm going to talk about this in a minute. All right, this becomes u to the third power, and this makes my du. So u to the third power times du. Okay, so now we've switched this integral from being taking the integral with respect to x to respect to u. Now this 0 and this 1 right here, those are x values, not u values. So what we have to do is we have to switch these to u values. Well, how do you get u values? Well, we have a relationship right here that u is the same as x squared plus 1. So what we're going to do is we're going to write u, and that's going to equal, and we're going to put this lower limit first. It doesn't matter which one you do first, okay? And we're going to square 0, and we're going to add 1. So 0 squared is 0, plus 1 is 1. So this lower limit that was 0 is now 1, okay? And then u is equal to, we got to do the upper limit. So this one would be 1 squared, because x is 1 for that one, and then plus 1. So that'd be 1 plus 1, which is 2. And so this is the upper limit would be 2. Now I'm going to add some notes to this, okay? Okay, we always need to remember this. This actually is going to make the problem much easier if we switch to use. So on my prior notes from previous years, I always write this. Remember to change the limits of integration to values of u. Okay. All right, so I'm trying to use color to help you see everything, okay? All right, so now this is really, I'm just gonna rewrite this, okay? So this becomes the integral of 1/2 times the integral 1 to 2 of u cubed du. This is a really easy integral now, okay? So we add 1 to the power and divide by it. So we have the 1/2 times, and u cubed becomes u to the 4th divided by 4. That's the antiderivative of it. And remember, on definite integrals, we don't have to put the plus c because, well, I'll talk about it again in just a minute. We're going to go from 1 to 2, okay? And then this becomes 1/8 u to the 4th, or u to the 4th over 8, evaluated from 1 to 2. I'm going to slide that up. Sorry, I forgot to slide that up. Okay, so u to the 4th over 8, evaluated from 1 to 2. Okay, now we don't need that c, because if we put it in, we'd have a plus c, but then we're going to minus the c. Remember, they'll cancel each other out. That's why we really don't need to do this. Okay, so remember to put the upper limit in first. So this is going to be 2 to the 4th over 8, and then minus 1 to the 4th over 8. Well, 2 to the 4th is 16. So this is 16 eighths minus 1 to the 4th is 1. So that's 1/8. And so the answer to this is 15 eighths. Okay, and that's our answer to our first question. Okay, for this next example, we're going to take the integral from 1 to 5 of x over the square root of 2x minus 1. And inside the square root is 2x minus 1, so I'm thinking that's the one I'm going to want to let u be. Okay, so let's try that. Let u equal 2x minus 1. And then du would be 2 times dx. Okay, so for this, this doesn't take care of this x right here, but remember, we could solve this for x and change this x to in terms of u. All right, so this is equivalent to the integral from 1 to 5 of x over the square root of 2x minus 1. And then I'm going to multiply by, now I need a 2 dx, right? So I'm going to multiply by 1/2 and also multiply by 2. So 1/2 times 2 dx. And this is going to be my du. Okay, so I'm going to come off to the side here. Okay, I'm going to keep going to the right. This is equivalent to, I'm going to bring this 1/2 out because this 2 dx is my du. Okay, and then this 1/2 is going to come out. So 1/2 the integral of x. Actually, I take that back. I'm going to start switching some stuff to u's. Okay. So fraction bar right here. This is going to be, this becomes the square root of u. This 2 and the dx become my du. This 1/2 I pulled out, right? That's the 1/2 right there. So this is du. Okay, so now this top is x, right? But x is going to become, and we solve this for, remember, we solve this for x. So u equals 2x minus 1. Solving for x, we get u plus 1 is equal to 2x. And that'd be u plus 1 all over 2 is equal to x. Okay, so this x and the u plus 1 over 2 are the same. So this is, you know what, let me rewrite this. This is dividing by 2. Dividing by 2 is the same as multiplying by 1/2. So I could also write it like this: 1/2 times u plus 1 is equal to x. These are equivalent, okay? So up here, I'm going to write 1/2 times u plus 1, okay? Now, we've switched everything to u's, so that means I need to switch this lower limit and upper limit to u values, okay? So u, for the lower limit, u would equal, okay, 2 times the 1 minus 1. Okay, so this is the u is 2x minus 1. That's where this comes from. And why am I putting in the 1? Because the lower limit right here is 1, and that's this 1 right here. So 2 times 1 is 2, minus 1 is 1. So this stays 1, okay? Now, for the upper limit, that is 2 times my x, in this case my x is 5, minus 1. So 2 times 5 is 10, minus 1 is 9. So the upper limit in terms of u becomes 9, okay? So now a few other things that we can do, all right? This 1/2 can come out. It's just a constant, right? I'm multiplying by 1/2. That means I can pull it out. So I'm gonna have 1/2 times 1/2 out here, all right? So 1/2 times, I'm gonna go ahead and write it, 1/2. I wanna make this really clear for you guys to see, okay? I'm doing my very best. It's hard when it's just video and I can't see your faces and see if you're getting it or not. Okay, so I'm trying to show more detail than I normally would. Okay, so this is gonna be an integral from 1 to 9, okay? And this is gonna be u plus 1 over, okay, and the square root of u, okay, because this is u's, we have u's on top, and this is just the square root of u, I'm gonna rewrite this using exponents. So the square root of u is the same as u to the 1/2 power, and then my du. So 1/2 times 1/2 becomes 1/4. The integral from 1 to 9. Okay, and this came from adding two fractions with a common denominator of u to the 1/2. So this becomes u over u to the 1/2 plus 1 over u to the 1/2 du. Okay, and now, okay, so we have the same basis. Okay, this is a power of 1, so it'd be 1 minus 1/2, or 2 halves minus 1/2. So this is going to become u to the 1/2. Okay, so that's 1/4 the integral from 1 to 9 of u to the 1/2 plus, and 1 over u to the 1/2, well, we can rewrite that with a negative exponent. So this is going to be plus u to the negative 1/2 and then du. And we could put parentheses around this. It wouldn't be wrong to, okay? But anything between the integral and the du is what we're integrating, okay? Okay, so this becomes, now we're gonna do the integral of this, the antiderivative. So this would be 1/4 times, okay, so we're gonna, remember when they're fractional exponents, we're gonna wanna leave a little bit of space in front, okay? So this is u to the 1/2, so we're gonna add 2 halves to this, because that's adding 1, and we're gonna divide by that new power. So this is gonna be u to the 3 halves, divide by 3 halves, but dividing by 3 halves, it's better to multiply by the reciprocal. So instead of dividing by 3 halves, to multiply this by 2/3, and then plus, I need to add 1 to this exponent. Okay, so that'd be adding 2 halves. So leave some space. This is gonna be u to the 1/2, okay? And I would divide by 1/2, but a better way is to multiply by the reciprocal, which would be multiplying by 2, or 2 over 1. I'm just gonna write 2, okay? And I'm gonna close this, and this I'm gonna evaluate from 1 to 9. Okay, so cleaning this up a little bit, before I start evaluating from 1 to 9, I wanna distribute the 1/4, okay? So this would become 2/12, but 2/12 is just 1/6. So this is 1/6 u to the 3 halves power plus, and 1/4 times 2 would be 2/4, or that would be 1/2. 1/2 u to the 1/2 power, and we're going to evaluate this from 1 to 9. Okay, so this is 1/6 9 to the 3 halves power plus 1/2 times 9 raised to the 1/2 power. I'm going to close my bracket here, or put a bracket around that. And then when I'm minus, putting the 1 in, okay? So then bracket, and I just realized I hadn't been sliding this up. Sorry, guys. So let me give you a few seconds to copy that down. I was saying it, but go ahead and copy it down. Okay, you can also pause it, you know. Okay, so if you get behind in the notes, always just pause the video and you can catch up, okay? That's what's nice about doing these on videos. All right. So now we're going to put 1 in. So this is going to be 1/6 times 1 to the 3/2 power, and plus 1/2 times 1 to the 1/2 power, and close the bracket. Okay, what do fractional exponents mean? Okay, the bottom number, the denominator, okay, that's the root, and then this is the power. It's better if we can try to take the root first and then raise to the power, okay? So this becomes, I'll use a bracket, 1/6, okay? And then this would be, the 2 means a square root, so the square root of 9. We can take the square root of 9, that'd be 3, and then cube that, because we're going to cube it because of the 3 here. So that'd be 3 cubed, which is 27. So I'm going to multiply this by 27, and then plus, and then 1/2 times, okay, the square root of 9, well, that's 3, and then minus, okay, and then this would be the square root of 1, which would be 1, cubed is 1, times 1/6. So that's still be 1/6, right? 1/6 times 1, or just 1/6. And then plus, okay, the square root of 1 is 1, so this would be plus 1/2. I'm going to close my bracket. Okay, so this becomes 27/6, and this is plus 3/2. I would leave it like this because over here we have 6 1/2 also, okay? And then we're going to do minus 1/6, and then also minus 1/2. Okay, so 27/6 minus 1/6 is 26/6, and 3/2 minus 1/2 is 2/2, so that'd be plus 2/2. Okay, now 26/6, we can reduce this. These are both even numbers, right? So this is going to become 13/3. So I'm going to come off to the side here. I'm going to slide up before I forget to slide it up. So this would be 13/2. Yeah, no, 3. 13/3, and then plus, and this would be 1, right? Because 2/2 is 1. And now to get a common denominator, I'm going to need to multiply this by 3/3, or I'll go ahead and show it, 3/3. So this winds up being equivalent to 13/3 plus 3/3, which winds up being 16/3. And that's the exact answer to this, okay? Now, you can use your calculator to check your work, all right? So I'm going to come back up here. We got 16/3, right? So I'm going to grab a graphing calculator, okay? And I'm going to turn it on, okay? I'm going to clear this out. Okay, so if you press alpha window and then choose function integrate 4, okay? We're going to go from 1 to 5. I'll slide this up so you can see my button pushing to, and I'll zoom out a little bit. Okay, and then alpha for the fraction bar, alpha x for the fraction bar, and then x over, and then the square root, and then 2x minus 1, and then x. And we get 5, and then we can change that to a fraction. And we get 16/3, okay? So you're seeing we're getting the same answer that we got by hand, okay? All right, so you can always check your work doing that, okay? Okay, for this next example, we're going to integrate from 0 to pi/6 of cosine of 2 theta raised to the -3rd power. Now remember, when you see this exponent like this, it's really parentheses around the cosine 2 theta and raise it to the -3. So that's the cosine 2 theta would be the inside function to the -3 power function, okay? And then sine 2 theta and then d theta, okay? So looking at this, okay, we have a couple different inside functions, okay? So we have inside this -3 power, we have cosine of 2 theta, all right? Inside the cosine, we have the 2 theta, all right? So what would be a good choice to make u be, all right? So thinking about this, okay, if I let u be cosine of 2 theta, I know the derivative of cosine has something to do with sine. So it's like sine 2 theta, right? Okay, it's not quite sine 2 theta, but right? So that we pick up, if we let u be cosine 2 theta, we pick up the sine 2 theta along with the d theta, right? Now we may have some extra stuff, okay, but we'll be able to compensate with that because it'll be constants, okay? So in this case, let's let u be cosine of 2 theta, okay? Because that will allow me to pick up this part of the integrand, okay? So we're going to let u equal cosine of 2 theta, okay? And then du is equal to, okay, so the derivative of cosine is negative sine, right? So it's going to be negative sine of the same angle 2 theta times the derivative of 2 theta, which would be 2, and then d theta, okay? So really the negative and the 2, I'm going to need to get that in somehow into the integral, right? And that's easy because those are just constants, okay? All right. So now let's start rewriting this, okay? So this is equivalent to the integral from 0 to pi over 6. Okay, and I'm going to write this cosine of 2 theta, and I'm going to write it this way. So raised to the -3 power. And then times, right? Sine of 2 theta. And then times, okay, so I need to pick up a -2, right? So I'm going to multiply by -1/2 times -2, because that will give me, okay, that's really just the number 1, right? And then my d theta. Okay, so the sine 2 theta right here, along with the -2 d theta, that's going to make up my du, right? Or not du. Yes, I'm sorry, I was right, du. This -1/2, we really don't need. And then this part right here, this cosine 2 theta is going to be my u. So this is going to be my u. And so really what's going to happen is this is going to become u to the -3. We're going to have to integrate u to the -3. That's a pretty easy integral to do, okay? All right. So this -1/2 is a constant that's not really needed. Okay, we need it for the -2, but it's not really needed in the antiderivative part of it. So we're going to bring it on the outside of the integral. So this is going to be the integral of -1/2 integral, right? And then remember, we have to change the lower limit and upper limit to u values, okay? So this is going to be u to the -3. Okay, and then the rest of this is going to be my du. Okay, so now we got to integrate, or not integrate this. We got to find the lower value and the upper value. Okay, so we know that u is cosine of 2 theta. So u is equal to cosine of 2 theta. So this is going to be cosine of 2 times, and my theta in this case, because these are actually thetas, the 0 and the pi over 6 are theta values, is going to be 2 times 0. So 2 times 0, which is cosine of the angle 0. Okay, I'm going to draw a little diagram here because we haven't been the best at this, okay? So where is angle 0? Angle 0 is right here on the positive x-axis, and when it lands on one of these axes, we're just going to use the radius of 1 around the circle, okay? So I know my r is equal to 1, my x would have to be 1, and my y would have to be 0, right? Okay, so what's cosine? It's your x over your r. So this would be 1 over 1. So this would be 1. Okay, so our lower limit changes from being 0 to 1 in terms of u. Okay, so now let's do it for pi over 6. So u is equal to cosine of 2 times your angle, which is pi over 6. Okay, and that is cosine of 2 pi over 6, which is really pi over 3. Okay, so I'm going to draw a diagram for this. And where is angle pi over 3? Pi over 3 is in the first quadrant. So I'm going to draw my diagram in my first quadrant. This is the angle of rotation, pi over 3. Okay, always opposite pi over 3 is the square root of 3. So this leg has to be the square root of 3. And since it's in the first quadrant, this is a y, it has to be positive. So positive square root of 3. My hypotenuse and radius is 2. And then this horizontal leg, the x value, right, is positive 1. And it has to be positive because it's on the positive x-axis, right? It's all in the first quadrant, okay? So cosine is my x over my r. So this would be 1 over 2. So this upper limit changes to 1/2, okay? All right, so then next is, okay, let's start doing the antiderivative of this, okay? So this is equivalent to negative 1/2. And I'm going to add 1 to this power, right? So times, and then u to the, adding 1 to negative 3 makes it negative 2. And then I'm going to divide by that new power of negative 2. And I want to evaluate this from 1 to 1/2, okay? Now, this, I'm going to clean this up a little bit before I start plugging numbers in, okay? All right, so this would be, this is a negative times a negative. That's going to be a positive. So this becomes 1/4 times u to the negative 2 power. Okay, evaluated from 1 to 1/2. But u to the negative 2 is really 1 over u squared. So this is 1 over 4 times 1 over u squared, evaluated from 1 to 1/2. Or 1 over 4 u squared, evaluated from 1 to 1/2. Okay? So, okay, so we're going to put 1/2 in this, right? Okay, I'm going to slide this up before I forget. I'm trying to be good at that, okay? All right, so this is equal to 1/4 times 1/2 squared. And then minus 1 over 4 times 1 squared. Okay, so this would be 1 over, okay, so 1/2 squared, 1/2 squared would be 1/4. And 4 times 1/4 would be 1. And then minus, and then this would be 1 squared, which is 1, so this is minus 1/4. Okay, we could multiply top and bottom by 4 over 4, right? And we would get 4 over 4, which is also 1 minus 1/4. And 4 over 4 minus 1/4 is 3/4. Okay, and that's our answer to this one. Okay, so we can go back, and I'm going to use a calculator to double check this. Okay, and you can always do this. I'm going to zoom out a little bit so you can see the entire calculator. Okay, so I'm going to turn my calculator on. Okay, and this time I'm going to go alpha and window, and then function integrate, and I'm going to go from 0 to pi over 6. Okay, so pi is right here, so second pi divided by 6, that's pi over 6 too, right? And then it was parenthesis, and then we need cosine of 2. Okay, it's going to type x, but it's theta, okay? Parenthesis, Okay, close the parenthesis for that. All right, now I'm surrounding cosine of 2 theta with parentheses. So I need to then raise that to the -3 and then come down out of the exponent and then times and then sine of 2 theta. We're gonna have to use x though. Okay, and then we're gonna take the integral with respect to x. And we should get 0.75, which if you press math, you can change it to a fraction and it gives us 3/4. The answer is a fraction, which is exactly what we got on our answer. Okay, all right, so that's how you do example 3. Okay, for this final example for today's lesson is example 4. We want to integrate 0 to 2 of e to the x over 3 plus e to the x dx. Okay, so if you look at this, all right, what should we let u be? Okay, because this, we don't recognize this as being the derivative of something, okay? All right, so if you let, what happens if we let u be the bottom here, okay? The 3 plus e to the x, okay? So let's take a look. If we let u equal 3 plus e to the x, okay? If we take the derivative of this with respect to x, okay, then this 3 is going to be 0, and the derivative of e to the x is just e to the x. And then we have our dx. So like letting u be this, okay, this is when we do our du, it's going to pick up this e to the x on top and the dx. Because when we take the derivative of this, so du, it's going to equal 0 plus e to the x, right? Or just e to the x and then dx. So by doing it this way, by letting u be this denominator, okay, it picks up this e to the x and the dx to make your du. All right, so this is going to be equal to the integral of, and I'm going to hold off on these lower limits and upper limits because we're going directly to switching everything to u's, okay? Because we don't need to make any fixes because there's no constant that we need, all right? Okay, so this becomes this e to the x and the dx make up my du, right? Okay, so it becomes 1 over u, and then that e to the x and the dx makes up my du, and that's an integral that we should recognize at this point, okay? All right, so what's our lower limit and our new upper limit in terms of u? Okay, so our lower limit would be u is equal to 3 plus e to the 0, and e to the 0 is 1, so this would be 3 plus 1, which is 4, okay? And then our upper limit is 2, so that'd be 3 plus e squared, okay? So our upper limit's 2, so we put 2 in here for x, so 3 plus e squared. There's really no way you can rewrite that any other way. So this is, I'm doing this example to show you, like, okay, you can have upper limits that are a sum of 2 numbers, okay? Especially if you can't calculate it, okay? All right, so the lower limit is 4, and the upper limit is 3 plus e squared. Okay, so then what does this become? Okay, well, what is the integral of 1 over u du? Well, we should know at this point that that's the natural log of the absolute value of u, and then evaluated from 4 to 3 plus e squared. Okay, so we're going to put the upper limit in first. So this is equal to the natural log of the absolute value of 3 plus e squared, and then minus the natural log of the absolute value of 4. Okay, now you want to ask yourself, because sometimes it's going to be easier, we're going to be able to use other things, okay? If you look at this and go, okay, do we have to have the absolute value? Okay, we do when we do the antiderivative, but when we put these values in, okay, so for instance here, this 4, okay? 4 is already positive, so you really don't need the absolute value. So we're going to remove them, okay? And 3 plus e squared, well, e is about 2.7, and when you square that, that's going to be positive. And 3 plus this positive number is going to be positive. So this is going to be positive. So really, we don't need the absolute value at all on this, okay? We would only need the absolute value if this turned out to be negative, and we would need to keep it then, okay? All right, so then we can rewrite this now as the natural log of 3 plus e squared minus the natural log of 4. And that's a perfectly valid answer, okay? However, there's a logarithm property that we could use to make this, to do one more step, okay? It's so funny because I'm teaching this right now in Honors Math 3, all the logarithm properties, okay? So if you remember from last year, okay, if we had the natural log of A minus the natural log of B, we could write that as a single logarithm, and it would be the natural log of A over B. And we could put parentheses around this, we wouldn't have to, okay? So whenever you're subtracting two logarithms that are the same base, and these are both natural logs, so they have the same base of E, all right? When you subtract them, you can write it as a single logarithm, okay? And the numerator would be the thing that you're taking the logarithm of first, and then the denominator would be the logarithm, or the thing that you're taking the logarithm of second here, okay? So back to this problem, this could be rewritten as the natural log of 3 plus e squared over 4. Okay, so I'm going to go back to my calculator, okay? And we could get an approximate answer out of this. I mean, okay, all right, this can't be written as a fraction, okay, because we're taking the natural log of it, okay? So I'm going to zoom out a little bit. Okay, and so we're going to have to compare this answer to what we get when we do the integral here, okay? I'm going to clear out the previous problem, okay? And let's go alpha, window, and number 4. We're going to go from 0 to 2, and then alpha, x for the fraction bar, and then e to the x is, we have to press second, e to the x, and then the denominator was 3 plus e to the x, and dx, okay? And we get an answer of 0.954. So we could, okay, write this approximately. This is approximately, remember, to 3 decimal places, 0.954. Okay, now let's put this in, and I'm going to show you that this is the same value, okay? So ln of 3 plus alpha e squared over 4. And I'm going to show you that this integral and this value are the same. And look, they are. Okay. All right, guys. So that is the last example for this last, or not last lesson, but this last, well, it is the last lesson on integration by substitution. Okay. I'm going to put the calendar up, the assignment sheet up next, and I'll talk about that. Okay, guys, so here's the assignment sheet, okay? And what I'd like you to do is assignment 8-5, which is worksheet 8-5. And again, this is the date that I'm recording this. This isn't necessarily the date that you're going to put on here or the date it's due in Google Classroom. It's just when I recorded it, okay? All right, so today is the 23rd. Okay? Do not, please, 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 do not hesitate to reach out to me on Remind, or on Google Classroom, or email me any questions you might have. We could set up a Zoom chat, just if it's just an individual question, or if we can just do it through email or whatever else. I'm here for you. I'm here to help you out to get through all this, okay? And we're gonna be okay, guys. We're actually in a much better shape than a lot of other schools. From the emails I'm getting from other AP Calculus teachers, okay? So you guys are doing good, okay? Just hang in there, stay tough, make sure you're doing these assignments, and so that you're ready for the AP exam, whether you take it from home or we're back in school or whatever it might be, okay? You guys have a blessed day. Take care. Bye.